We now move on to some simultaneous equations that are definitely a step up in difficulty. You won't be surprised by the start. But now if we look at these, there's a problem. If we try subtracting them, we're going to get perhaps 3x take 6x, negative 3x. 4y take positive, so 4y take 3y makes a single y. We can't eliminate either of the letters, which is the whole point of this method. So we've got to try something a little bit cleverer. We're going to look for a number which we can multiply either of the equations by. But you can't decide what the number is if you don't know the purpose of it. So remember that we need to make sure that either the x's match up so that we can subtract and get rid of them, or the y's need to match up so that we can subtract, or I should have said add a minute ago, and get rid of them. Notice that this 3, if we were to double that 3, it would match very nicely with that 6. That's a big clue. So we're going to take equation 1 and we're going to multiply it by 2. So this is a brand new step that sometimes needs to happen at the beginning of these questions. Equation 1 multiplied by 2 all the way across becomes 6x plus 8y equals 36. Now, this is still based upon equation 1, but it seems sensible to give it a new label. Now, equation 2 and equation 3 should be able to work. So let's see what we can do with these. Equation 2, take away equation 3. Let's see what happens. 6x, take away 6x, the x's disappear, everything's good, we like this subtraction. So we follow it through. 0, positive 3y, take positive 8y. Take positive, as we've seen before, that will combine to make a negative. So 3y, take 8y is negative 5y. And 21 take 36 is negative 15. Now this is a little bit awkward because of all the negatives. I'll just comment that we could have done our subtraction in the opposite order. We could have done equation 3 take away equation 2. If we'd done that, we'd have got 6x take 6x makes 0. 8y take eventually 3y would make a positive 5y. And 36 take 21 would have made a positive 15. So perhaps it would have been cleverer to do equation 3 minus equation 2. Nonetheless, it works, because if we solve this equation, to get y on its own, we need to divide by the thing multiplying the y, that is, the negative 5. And we need to do that to both sides. Now, negative divided by a negative makes a positive. 5 divided by 5 makes 1. And so this does become the single y that we want to know about. On the right hand side, again, a negative divided by a negative is a positive. 15 divided by 5 is 3. We've discovered the y value. What happens next shouldn't surprise you too much. Substitute y equals 3 into, now we can use any of the 3 equations, but really we should go back to the first 2 original ones. I would judge that the first one is slightly simpler because it just has slightly smaller numbers. So I'm going to substitute y equals 3 into equation 1, so that 3x plus 4y equals 18 leads us to, when we substitute that in, 3x plus 4 times 3 equals 18, that is 3x plus 12 equals 18. Take 12 from the left hand side and from the right hand side. 3x equals 6. Divide both sides by 3, and x equals 2. These lines that we started with, if we're correct, will intersect at an x value of 2 and a y value of 3. Let's just check that. Check in, I used equation 1 there, I'm going to use equation 2 now. Equation 2 said 6x add 3y equals 21. Find out if it does. 6 times 2 add 3 times 3, 8, not 8, hear me, 12 add 9 does make 21. It's correct. Notice how easy it is to make a stupid mistake. I was just getting towards the end of that question. I was starting to probably mentally relax a little bit, and I stopped thinking. So easy to go wrong when you've done all the difficult stuff already. Now, moving on to one more question along these same lines. Let's just try this one. 4x add 5y equals 17. 3x take 10y equals minus 1. Equation 1, equation 2. We have the same problem as last time. These are never going to cancel each other out as they stand. Neither are these, because the numbers, the coefficients on the front of the letters, don't match each other. So we're going to have to do some thinking. I'm noticing that the 10 is double the 5. So I'm thinking to multiply equation 1 by 2. What have we got? 8x add 10y equals 34. And I'm going to call that equation 3. I think I didn't do this last time. I think I shall rewrite equation 2. 3x take 10y equals minus 1. That's equation 2. And I'm going to try, we'll see if it works, but I'm going to try equation 3 take equation 2. Let's put those negatives in there. Now does this work? 5x there. Positive 10y plus 10y makes 20y. We haven't managed to eliminate the letters. Subtraction is the wrong choice. Change all of these to additions. What have we got? 11x positive 10y minus 10y does make 0, good. 34 minus 1 is 33. Divide through by 11. Discover that x is 3. Substitute x equals 3 into, I'm going to go with equation 1. 4x add 5y equals 17. 4 times 3 add 5y equals 17. 12 add 5y equals 17. Discover that y is equal to 1. And then you can check it in the usual manner.